Hello! In this video, we're going to explore the effective range for beta particles and what can stop them. We will perform an experiment in order to investigate these points. We will use a Geiger-Müller tube that measures the received counts per minute from the radiation source, and we need a beta source. Notice that at a small separation distance, there are 960 counts per minute measured by this counter, and when the distance between the beta source and the Geiger-Müller tube is increased, the registered counts per minute by this counter decreases. When this distance is about 50 cm, the registered counts reduces to 20, which is equivalent to the background radiation. This indicates that the range of beta radiation is about 50 cm in air, which is larger than that of the alpha radiation, that was about 5 cm in air. Moreover, if a paper is inserted between the beta source and the Geiger counter, the registered counts reduces from 640 to 600 counts per minute, meaning that the sheet of paper has a little effect on the registered count rate. However, if a thick card is inserted between the beta source and the Geiger counter, the registered counts reduces from 640 to 500 counts per minute, meaning that the beta particles are partially absorbed by this card. However, a 1 mm thick aluminium sheet affects significantly the count rate when it's inserted between the beta source and the Geiger counter. And if the thickness of this aluminium sheet is increased, the count rate decreases further. And remarkably, the beta radiation is completely absorbed when the thickness of this aluminium sheet is about 5 mm. That's all. Thanks for watching.